computer. All right, we should be recording, hopefully, yes. And the videos from yesterday, both morning and afternoon sessions, are on the YouTube channel. They're just the first two videos for uploads here. They're also in playlists if you look for the newest playlist here. Let's see, not Mom and Dad, not that one. Let's see, SEM Boot Camp 2019. Both videos are in there. So we should be good. I'm going to close that. Today, let's see, yesterday we ended on EFA. We finished an EFA and ended up with this pattern matrix. There was a request to just show one more time how to get factor scores out of the pattern matrix. So I'm going to show that one more time. What you would do is go to Analyze and Dimension Reduction, Factors, do your factor analysis. And then when you're doing your factor analysis, you're going to look in the Scores button right here. Click on that, and then there's an option to save as variables. And if that's checked, then every factor will save as a new variable. So hit Continue and hit OK. And when this runs, it'll just run regular EFA. You won't notice anything special, except if you go back to your data set, you'll see at the bottom, you'll have these new factors. Looks like I've been saving several. Whoops. There they are. Lots of factor scores. It'll just be the most recent ones. And in this case, these ones right here. And then you'll want to name these based on the factor number from the pattern matrix. So if you go back to the pattern matrix, you can see factor 1 is down here, usefulness. That's what loaded on factor 1. So you would name factor 1 something like useful FS for factor score and carry on and name them all. Anyway, that's how you do it. Hope that works for whoever. I think it was Chris. I'm going to delete these. Deleted. Okay. So now we have this finalized file and this finalized output. I saved this output in the Google Drive if anybody wants the pattern matrix for what we're going to do next. We're going to talk about the CFA today. We'll see how long this takes. It used to take a whole day, but I've created some tools and plugins to make it go a lot faster. So hopefully we'll be able to get through the whole thing. Who knows, maybe even before lunch, but that'd be ambitious. And then after lunch, we'll see how things go. CFA is good for a lot of stuff. It's probably the biggest part of your SEM process. It requires you to look at model fit, at all the validities we looked at yesterday, reliability, and also look at invariance if you're doing a multi-group analysis, at method bias if there's potential for method bias. So that it's a really involved process. And instead of just going through the slides, I'm just going to do like yesterday and be in the software and discuss it through the software. And then we'll come back to the slides and make sure I haven't missed anything. So let's do that. Open up Amos. Who here has never used Amos? All right, you're in for a curious treat. Go find Amos and open it up. You should see something like this when it opens. Let's see, remote folks has a chat question. First time using Amos from Lynette. All right, well, this will be fun. So get it open, and there are several things we need to do to start. I guess I'll just introduce the interface to you, and then we'll start using it productively. So while it's opening, let me just show you some stuff. This is the canvas where you draw your models. Your models will end up looking something like messes like this, something like that, who knows. Whoa! These are models people have emailed me, and I've had to help them out. These are just all in my stats service folder. We'll make something that looks a little more like this, I hope. A little less like this one. So, but you just want a new file, just a blank file. And the first thing you need to do in Amos when you're creating a model is you need to link the data, which is either file data files, not file open, that's something totally different. Or you can click on this little spreadsheet looking thing right here next to the colored abacus, and that's to select your data files as well. And if you were to do that, let's go ahead and do that together if you have it open. Click on this spreadsheet thing or go File, Data Files. And this window will open. You'll click on File Name. Who's still waiting for Amos to open? Okay. Click on File Name, and then you can search for the file. For us, it would be in Google Drive or wherever you've saved it. Downloads folder, probably. And we'll be using the, oops, not Excel file. We'll be using a .sav file. And for us, it's this 2019 Boot Camp Original, no missing, trimmed. Open. And if it reads it correctly, you'll see that an N pops up. That's the sample size. And if no sample size pops up, it's not reading it correctly, go find it again. And then hit OK. In order to stay on the same page, you have to follow along, like be on the same page up through the first several steps. So if I go too fast, just stop me.
Can you say the file name you're using one more time?
Yeah, the file name is this weird one, Boot Camp Original. No, it's 2019 Boot Camp Original, no missing, trimmed. Yeah, that's quite descriptive. And once you have that loaded, you'll be able to click on this white stacky thing. I'm not sure what it's supposed to represent. Maybe like a database or a list of some sort. If you click on that white stacky thing, you'll see all the variables in your data set. And then you can start pulling them in. We won't really do this, just watch for a sec. You can just pull variables in. Unfortunately, you can't pull like 5 in at a time. You just gotta do them one at a time. But we're not gonna do that. Let me delete these. We're going to create a CFA, which is a measurement model. And again, maybe don't do this unless you're feeling comfortable and risky. There's this little candelabra thing at the top. I don't know what else you call it. Maybe like claws or anyway. It's a little candelabra thing. If you click on that and then click over here in your canvas area, it'll create a latent variable, which if you click, it'll create items on that latent variable. And you can do that as much as you want. If yours is creating like really tiny latent variables, you can click and drag to make it the size you want. And then that becomes the default size from here on out, or until you resize it again. So I'm just gonna delete all that. But I guess before I delete it all, what you would do typically without plugins is you would create this measurement model based on your final pattern matrix. So we have factor 1, which is usefulness. We have 7 items on usefulness. So we'd create a model, a latent factor here with 7 items. And then we go to this white stacky thing and we drag usefulness, 1, 2, 3, and so on, over here. Oh, look at that awful thing. There's this default setting in Amos that displays labels instead of names. We'll have to fix that. So anyway, we go and drag all those in. It's kind of a pain. Let's change a setting real quick. Go to, oh, is somebody talking? Somebody need something remotely? That's cool. Somebody's there. Lori, I'm gonna mute you, Lori, unless you're, there you go, thanks. Okay. All right, anyway, there's a setting. If you go to View Interface Properties, sorry, motion sickness. View Interface Properties. And go to the Miscellaneous tab. There is a checkbox for Display Variable Labels. Uncheck that. Because what we were seeing when we dragged variables in was the whole label, like the whole survey question. We don't want that. So again, that was in View Interface Properties. And then Miscellaneous tab, uncheck the Display Variable Labels. And then just hit close. There's no like OK or save or apply, just hit close. Okay, and then it'll show just the variable name here instead of the whole label. But again, we don't really want to build it this way. There are faster ways to build it. So I'm going to delete all this, erase all. Yay. Okay, you won't have that. For those who are looking to erase everything that you created, you can use this little I got to create a variable now. Here. You can use this little X marks the spot icon. Click on that. That's the delete. And then you can go and delete stuff that way. Okay. It's kind of a janky early 90s interface that has never been updated, like ever. When IBM bought this back in early 2000s, they just left it the way it was and haven't really updated it since, except they make a new version every year, so you have to buy it. So that's how it works. All right, so let's create a CFA. But to do that, the fastest way is going to be to use plugins. If you were to go to our folder, our shared folder, and go to the Estimands and Plugins folder, open that up. Most of you should have Amos version 24 or higher, probably 25 or 26. Anyone here have less than 24, version 24? Good, because that would make things very difficult. All right, so open up the version 24 or higher folder. And there are a bunch of plugins in here that my research assistants and I have created to make life less painful. This one right here, the pattern matrix builder, is what we want. What you'll do is you'll download that file. Don't open it, just download it. So if I were in Google Drive, I'd go click on it. Let's see, Drive. And SEM Boot Camp. Estimands and Plugins, version 24. All right, so if I were in here, I would find the pattern matrix builder. I would double click it and hit download. And if you're using Internet Explorer or anything, Microsoft Edge, it'll say, yikes, this is a driver file. Are you sure you want to download this? The answer is yeah. I haven't put anything malicious in this driver file, so you keep it. And it'll still probably block it. But once you download it into probably your downloads folder, go find it in the folder. Don't open that file. It won't do anything if you just open it. Go find it in your folder. And it'll be something like this. Am I going too fast? Good. This is a critical plugin. If you don't get this installed, it's going to be a pain in the rear. So do get this installed. Once you get it downloaded, right-click it and go to its properties. And there is a little checkbox down here that says unblock. Anytime you download a driver file from the internet, it'll block it automatically in Windows. So you've got to unblock it. Some of you might not have that if you have a different version of Windows. But if you do have that, make sure you hit unblock and hit OK. That'll be the same for any plugin we download. Now the tricky part is getting it to where it needs to be. It's a lot of setup just to get to build a model. But once you do it, it makes life easier. Stop me as we go if I'm doing stuff that doesn't make sense. If we get stuck. Yeah. All right. Okay. Okay, here's where you want to put it. You want to copy that file or Control X or Control C, either one. And you're going to go stick it over in go to your local C drive, your OSC. And then I believe you got to go to Users. Let me zoom in. And then go find your username. For me, it's Jay Gaskin. And then we get to a spot where ours is going to look different. Mine's going to look different from yours. You have to do this. Go up to the View tab. And there is an option to view hidden items. You want to view those hidden items because there will be folders that we need to get into that Windows doesn't want you to see. So check the box for hidden items. And that'll show all hidden files, hidden folders. Once you do that, you will then see this folder called App Data. Double click App Data. Go into Local. Go into Amos Development. go into Amos, and your latest version, which for me is 25, and plugins, we've finally arrived. Paste it in here. Who wants to follow and wasn't able to follow? Okay, where should I restart? From the beginning?
Maybe.
Okay. Were you able to download the file?
Yes.
Yeah, downloaded, but I couldn't get it.
Would it save to your computer at all?
It didn't look like it did.
All right. So what happens when you download a driver file is it'll warn you. Did you get the warning? Yeah. Did you say keep? Okay. And so now, can you find the file on your computer? Yeah?
It looks like it's in the download folder.
Oh,
but I can't-
excellent.
I can't take it from there.
All right, so in the downloads folder, the next step would be to, let me just show this. There we go. The next step would be to unblock it. Should we do that step?
Yeah.
So right-click the file and go to its properties. And once you get into properties, there should be in the general tab a little checkbox down here, which has disappeared for me because I've already unblocked it. But there should be a checkbox on the general tab that says unblock. So check that. Once you've checked that, it's ready to move. You can copy it or cut it and then go stick it back in this folder, which, oh wait, we got to do the unhide stuff first. Up in your folder view, there's a view tab. Click on the view tab, click on the hidden items checkbox on the right. So it's checked. Are you there? And then go to this path, see users, your username, and then app data, which is now visible. And for you, the Amos /25 might be /26 if you have the most recent version. Any luck there? Finding the right folder? No? I'm going to come around to you. Let me check the text real quick.
You want me to go look at that, James?
Yeah, if you can find it, yeah, that'd be great. And then I'm going to address these real quick. Let's see. The drive folder appears empty for some reason. SMANs and plugins. Oh. Are you trying to find the link? All right, so Raphael, if it appears empty, that's unfortunate. Let's see. Why would that be? Make sure you're in the right one. So SEM Boot Camp, estimands and plugins, go to version 24 or higher. And then hopefully there's some stuff in there. Or is that completely empty for you?
It's kind of crazy. My problem is I can't figure out how to access it. So I'm not really getting over with this. But I at least have Amos.
Completely empty. Well, dang. I'd email you the driver file, but email blocks it. I can't email it to you. I could send you a direct link, though, I bet. Let me see. Let me go down here and get a shareable link. That. And let's do this chat. Oh, somebody got it for you. Yeah, let's see if it's the same one. So, and here's another link to it. Maybe that works. Try that. We're good? All right. It is clunky. Like, it is hard to get set up. Not intuitive at all.
Yeah, when it comes to computer drive, one tool.
Yes. James might know. What's the path for the network driver you are using?
Yeah, I can't access it here.
Oh, you're on a Mac. Yeah.
Well, I'm just using the
You're using Citrix. I don't know if you can use the plugin in Citrix. So what I'll do is I'll save the file once I generate the model, and then you can just open up that file. So you won't have to generate it yourself. Yeah. Good. Sweet. That worked. Glad, Rafael, you got that. Thank you,
So where's
Rike.
your file?
Okay. We're just working out some bugs here locally. Thanks for your patience, remote folks.
Just check the properties of this.
Okay. For those who can't get the plugin all set up and working, don't worry about it. I will create the model and save it on our Google Drive, and you just use that file. Yeah, and you'll have these videos to refer back to if you want to do it in the future and figure it out. Or we can look at it over lunch. Unless you're using Citrix, then I can't help you with plugins, I think.
Okay, you know what? It's interesting because for mine, I think, did yours have this as right here where it says attributes? Yeah. That's where it
Chris,
said,
are you using
security.
Citrix? Any of you guys?
We use security for M+.
Okay.
At Case, they won't install plugins on the Citrix.
No, I don't think know that they can. Yeah.
So it doesn't give that
So
as
we
an
use
option
install
there, so we're going to
version
assume that
Okay.
it's good to go.
Let's see. Okay.
Yeah, I don't know. I assume that there's.
Did it work out for you?
So the only problem is on hers, it didn't give the allow.
Oh,
security was already
allowed?
It didn't give an option for that.
Okay.
And so I assume if we ran it, it would not work.
Yeah.
She doesn't.
Does it show up in Amos? Question.
Oh,
If you go to the
question.
yeah, Amos if you do plugin. If you go to the plugins menu, does it show up?
I also had the same issue with the plugin for mediation parameters in the past. Oh yeah.
Oh, okay.
Yeah, that's it.
Well, when we get to that, we'll have to see if we can troubleshoot that. Did it show up for you?
Yeah.
I think so.
Woohoo!
I didn't even try. I just saw how complicated it was in the past.
Oh, I'm
I gave up.
all right. I think we're all set locally. So let's do this thing. Okay. Thank you for all your patience. Setup is long, but then once we get into it, it moves a little faster. So what we want to do is we want to create a measurement model, a CFA, and we want to do it based on our EFA. And so you'll want to open the file. Let's see. Where did I put that file?
Right in the folder for the.
It's in the data folder, probably?
Nope, in
Nope.
the main folder for the boot camp.
Oh, it's in the main folder. Okay, so if you were to go to SEM Boot Camp folder, don't use the Word doc. Yeah, instead go to the data folder. You're good, don't worry about it.
What happens if you use the Word doc?
It shouldn't paste correctly.
Look like a dream.
Did it work for you in Amos?
Yeah.
Oh, that's awesome. Good. It's broken for me in the past. So I'm just gonna play it safe. Open up the 2019 final pattern matrix.spv, which should look like this with one or two EFAs run. They're identical. So we just want to copy one of them, go down to the pattern matrix. Again, that's in the data folder in our Google Drive, and it's just called the 2019 final pattern matrix.spv. If you open that up, you'll see this pattern matrix, which if you copy, then you can take it over to Amos. And we got to save our file here first. Save this file just by hitting the floppy disk. I'll save this as CFA initial. Yes, I'll save over it. So you can call it whatever you want. You can call it Bob. It doesn't matter what you call it. Something meaningful is helpful though. So CFA initial is saved. Are you having trouble finding the SPV file? Oh, dang. Well, I will be saving what I generate here as a file, and you can just open my Amos file, anyone who isn't able to generate the Amos file. But once this is saved, and once the data is linked, make sure your data is linked, the boot camp, original, no missing, trimmed. Once that's all linked, then in Amos, go to plugins, and hopefully you see, well, you'll see less than shown here, but hopefully you'll see Pattern Matrix Model Builder. This one, that's the plugin we just installed.
Pattern matrix, magic.
Oh, is there a magic? Oh, it is magic,
It is magic.
but it's called Model Builder, yeah. So you click on that, and this thingy opens up, and you just paste your pattern matrix in there. And then hit Create Diagram. And hopefully it'll work.
Voila.
Please work. Oh, it worked. It creates the model for you. And it's, yeah, it's all aligned and everything. So again, once the data is linked and you've saved the file, you go to Plugins, Pattern Matrix Model Builder, and paste in the pattern matrix that we just created.
Can I ask you a quick question?
Yes, of course.
I might be getting a little ahead. Can you just refresh on unstandardized and standardized?
What they are, what they mean?
Yeah, and I think it's always defaults to unstandardized, and I'm always struggling with Haven cases because it's in there, but Rick just was like, standardized is better.
Let's cover that as soon as we run this. I'll remember to cover that. Let me save this file so everybody has access to it. This is the CFA initial in the model in the Amos folder. So if you go to the Amos folder in our shared Google Drive, it is the CFA initial.amw. So if yours didn't generate, who tried it and it worked? Nobody. Oh, it worked? Yay! That's great. All right. For those for whom it didn't work, here's the file, CFA initial.amw. It's in our shared drive. It should be updated. If not, refresh your window. And we'll give it a sec. Getting set up in Amos is always a pain the first time. But again, then it starts working. All right, does anyone see it updated in the folder? Not yet. Okay. For me, looks like it just updated. Again, it's this one, CFA initial.amw in the Amos folder. You got it? All right, sweet. You find it? Maybe? Yes? Oh, good. Okay.
Anybody have any help with this? Not that I know much, but.
Know enough to get to that point. That's right. Okay, we're good? Okay. So once that's open, the first thing you'll need to do if you open.
Excuse me, I'm sorry. I was putting in, I got a little lost about, so when we were doing the save for the file and then opening up the other file, somehow I just had some conflicts with that and I got lost on which file I was opening.
Okay, for the model itself? You want to open the model?
Yeah.
So that'd be the CFA initial, this one.
I think maybe it wasn't the model, like before, so before we went to, remember right before we had to save our CFA initial, you were saying to open up another file.
Oh, the data set, yeah.
Yeah, and so I think that it just kind of, I went and saved one version and then kind of missed what happened after that. So basically I have the data file, it's open. What was the step that I was supposed to do next to generate?
So the next step, if you have this model open, you say?
No, I just had the data import or
You've got the data in.
data.
Okay. If you have the data in and you have the plugin, do you have the plugin?
Yeah, I have the plugin.
Excellent. Then what you want to do is you want to go and copy the pattern matrix. Do you have this?
Yeah, I have that.
Cool. So just right click that table, hit copy. And then back over in Amos, you'll go to Plugins and Pattern Matrix Model Builder right here. And when you click on that, it's going to reset mine. Cannot access. It's already run. It'll pop up a big empty window, and you just paste that table into that window and hit Create Diagram. Did that work out for you? Hello?
Yeah, it's telling me that the pattern matrix contains syntax errors or something. So
Oh, that's unfortunate.
that's okay. I'm using version 26. I don't know if that's an issue, but I'll just keep watching.
Okay, you can also just open up my file, my model file here that I saved to the Google Drive, and you can use this one instead.
Okay, thanks.
Yep. Okay. Once you guys have this open, if you're using my file, you'll need to relink the data because the data I link to is a different one than you link to. So go back to File, Data Files, and make sure the data is linked. You'll know it's properly linked if the N has a number, 378 over 378. If that N doesn't show up, then you need to go to File Name and go find that data set and relink it. Is anyone needing time to go link the data? Excellent. Okay, then we are ready. Yay! So here's your model. What we need to do first is we need to rename some of these factors. Factor names of 1, 2, 3 are terrible. You shouldn't name your factors that. So to rename a factor, you just double click on the latent factor. And this object properties window will show up. And instead of naming it variable name 1, we'll call this useful because that's what it represents. You don't want spaces in your variable names, or any mathematical symbols. We'll rename anxiety to anxiety. Let's see this next one here. Number 3 is playful. So click on 3 and hit playful. And 4 is decision quality. And 5.
James?
Yes.
I have never done that. So if I do a compute for the items to create the mean for, let's say, like the mean of the scale of playful, then I can put it instead of the numbers, or did I get this wrong?
So if you have just a mean for all of the variables, then it would just be one item, right?
Yeah.
For a whole factor. Oh, let me show you what we do with that. Let me save this, and I'll show you what we do with that.
Thank you.
Okay. Once you have those renamed, whoa, I zoomed way up. Just based on the name of the items, resave it, and don't do what I'm about to do. I'm just going to show something as an example. So what you would do, whoever was asking that question, is you would bring your data in as before. Let me just go grab it real quick. Oh, I have a button. This is elsewhere. Let's see, data, this one. Let's pretend for a moment that these down here are averages. In fact, they are. Like you can see, let me zoom in. These enjoy average, useful average, decision quality average. So instead of using the full range of items for enjoyment or usefulness or decision quality, I just averaged all those items. And in Amos, what I would do is I would just drag those in to a causal model. I wouldn't actually use these in a measurement model in like a CFA because they are no longer latent, and a CFA is only for latent factors. So if I created averages, then I would skip the EFA. But I'd strongly recommend if you create average, or only create averages if you're working with indexes like formative factors instead of reflective. If you have reflective factors, then definitely use, definitely go through the CFA process. All right, let's open up CFA initial again. Here it is. Cool. So you should have something that looks like this. If not, I saved this. You can open up this file. And let's do a couple things and then run it so you can see what it all means and what it looks like. If you were to click on this colored abacus, and yes, it is an abacus or Sorbonne, click on that. That gives you the model properties that we can, or the analysis properties that we can adjust. We want to go to the Output tab and check standardized estimates. And that's all. There are a bunch of other things we could do, but that's all we need for now. Just check standardized estimates. And there's no OK button, so you just gotta hit X and hope it saves. It will. And now we're ready, after saving the model again, we're ready to just run it, which is the black and white abacus.
James,
Yes.
I have a question on the constraints.
Yeah.
Is there any difference between constraining the regression weights or the covariances?
I think you mean the variances, not the covariances.
The variances, yes.
Yeah. So you'll notice every latent factor has a path constraint to one indicator. This path constraint of 1, which in Amos is required. It just provides an anchoring mechanism for the latent factor. And so every factor has to have at least one path constraint. If I were to delete this, the model wouldn't run. But what I think was Angel is asking is, do we have to have it there? Instead, could we stick it on the latent variable itself? For some of you, you're like, I don't know what you're talking about. That's fine. Like we could delete it here and instead put it right on the latent factor. And the answer is, yeah, you could do either. And the outcomes will be almost identical, if not identical. So either way, Angel, either way.
Thanks, James.
You're welcome. For those who didn't follow that, don't worry about it. Yep, that's an advanced topic.
James, doesn't it seem, though, maybe this is also an advanced topic, but it always seems arbitrary which one you anchor.
Yeah, so there is a method to anchoring. The default method is just anchor, Amos anchors the first one as it builds it. But if you want to do it like best statistical approach, what you do is you run this, see which one has the highest loading, anchor that one. But again, the difference is quite nominal.
But wouldn't it tell, though, the numbers, the factors, the coefficients for each of the other ones will tell how it compares to the one, right?
And it will, yeah.
So if you do it 1, if 1's greater than 1, that would have been a better one to do.
Exactly, you could anchor that one
So you
down.
could even do this, is run it with the 1 as it is, and the one that has the highest.
And then reset it, yeah.
Reset it.
Advanced topic, again, if you don't follow, don't worry about it. Okay, so we are ready now to save and run our model. It's just the black and white abacus. You run it, and an error occurred. No valid license. What? So this happens even if you have a valid license, and sometimes you just got, click through it, you just got to close Amos. Anyone else run into that error? Yeah, close Amos, all instances of Amos, and reopen Amos. Oh my goodness, yeah. One time though I showed up for a workshop and my license had expired the day before. Like for real expired. And that was painful. Yeah, that was awkward for a bit. I used Amos last night. I know it works, unless it expired this morning. Okay, so I'm gonna try it. I reopened it, I'm gonna run it, and it ran. So it was just a bad error. I don't know why they run into that error. When you run it, nothing actually happens. Let me look at this message real quick. Let's see. Can you landscape the model, please? Well, I could, but it's taller than it is like wide, so that wouldn't make any sense. It happens many times, as you said. Just close it and reopen it. Yes. If you do want to landscape the model, there's a way to do that. Enrique, you would go to View, Interface Properties, and then change it from Portrait here to a landscape. I'm not going to do that though because our CFA is taller than it is wide. So I'm going to leave it in portrait mode. Okay, so once you run it, nothing happens at all, except to the perceptive eye, this little arrow up here became red. So click on the red arrow and glorious things occur. then you'll be able to see all of the estimates on the model. These are unstandardized though, and the gentleman who asked the question about unstandardized versus standardized has left the room. So I'll answer that question now and later. Notice an unstandardized regression coefficient, or beta, or slope, it can range from any negative to any positive. It can be as big or small as it needs to be. But a standardized estimate must be between negative and positive 1. So we're going to look at the standardized estimates, which you'll see over here on the left. There's unstandardized and standardized. Click on the standardized. And when you do that, you'll see they all jump down to a relative scale. They've all been normed between negative and positive 1. If you have one that's greater than 1, then we have an issue. On this model, you shouldn't have one that's greater than 1. So we should be good. Anyone working on their own data have a standardized regression weight greater than 1?
I do when I do it unstandardized.
Oh yeah, unstandardized. Yeah, so unstandardized can be any size. It can be 1 million to negative 1 million.
So I was always playing around with like Haywood cases.
Oh no, these aren't Haywood cases. You got to look at standardized, and then if you have one that's outside the range, then yeah, that's a Haywood case. And if we run into that, let's fix it. Otherwise, I have a video for it. You can watch the video. Just Google Haywood case on YouTube and you'll find it. Okay.
We have to report standardized or unstandardized estimates.
Definitely report standardized estimates in a CFA. Yeah. Nobody's going to be too interested in your unstandardized estimates. The difference is if you were to standardize all your variables prior to running the CFA, then you could report unstandardized estimates because they would be standardized because you standardized the variables that went into it. Okay. Yeah.
Why didn't you have us go under analysis properties, output, check standardized estimates? Why did you have us check that when we afterwards had to collect it anyway?
Yeah, good question. So the question for the remote folks who couldn't hear, why go and select in the output standardized estimates if we're just going to have to recheck it anyway? The answer is the analysis won't estimate standardized estimates unless we check that box. So if we were to click on standardized estimates here, having not checked the box, nothing would show up. Yeah, Amos is awesome that way. Yeah. So this is your CFA. What you want to do is you want to examine, just sort of eyeball each factor. And remember, we want, for convergent validity, we want those loadings to average above about 0.7. And we want the lowest of those loadings to be no lower than about 0.5. So you can see useful looks fabulous. Those average out pretty high. No super low ones. Anxiety, we got a couple low ones like 0.66, 0.65, but it averages out just fine. Playful looks fabulous. Decision quality looks fabulous. Information acquisition looks fabulous. Social desirability, both the positive and negative scales, they don't look fabulous, but I'm not too concerned because they're just a control variable that we're not theorizing about. We're just using them as a tool to eventually control for method bias, or a specific bias, in this case, social desirability. So we're pretty good in terms of convergent validity. We can actually calculate the estimates, and we will. But just eyeballing it, we look pretty good. And if you want to look at discriminant validity, you look at these covariances. Well, in this case, they're standardized, so correlations. And you want no correlations above about 0.7. You can see here we have a 0.69. That's pretty high, but we're still okay, less than 0.7. Just looking through them. Looking pretty good. This is a pretty good model. If we want to know for sure, though, we can painstakingly manually calculate the AVE, which is not calculated by Amos. Either is the CR, or you can use a plugin for it. So, remember that painful process we just went through?
So you want all those
We can do it again.
of less than 0.7.
Yeah, these covariances, correlations, you want them roughly below 0.7, but it depends also on the loadings. So we'll use a plugin to see. Let me show you what the plugin creates, and then we'll go download it and include it. Let's see. What am I looking for? Validity and reliability test. I'll show you what this does. It runs through your model, makes a ton of calculations, and then reports a pretty little table with interpretations in there and suggestions if suggestions are needed. So let's figure out how to create this not manually. Whoa. Let's go get the plugin for it. Just as before, it's in that plugins folder in SEM Boot Camp, Google Drive, estimates and plugins, version 24 or higher. And this one's called Master Validity DLL. So you'll want to do the same thing you did before. Download that file, unblock the file, and then stick it back in that folder that's hidden super deep, way over here. No, not right there. Way over somewhere. Way over here.
Well, people are doing that. Can you bring that output file up and explain what?
Yeah, let me explain it.
I don't understand why the diagonal is not one. Why the constructs are not perfectly.
Yeah, let's look at that. Are we good on finding this plugin, putting it back into that folder? You haven't done it yet, probably, but you can do it. Don't forget to unblock it. Let me talk about the output real quick. So what it generates is a correlation matrix where plus a few columns. The correlation matrix starts here. Starts with useful here, this column. And inside the correlations, the non-diagonals, you have the correlations and their statistical significance. As indicated below here, 0.1, 0.05, 0.01, 0.001. And on the diagonal is not a correlation. On the diagonal is the square root of the AVE, which is also listed here, the AVE column here, and then the square root of that is listed on the diagonal. Because one of the criteria for discriminant validity, determining whether factors are truly distinct from each other, is the square root of the AVE greater than any of the correlations with another factor. So you want this diagonal value to be greater than anything below it or to the left of it in that correlation matrix.
I'm not good at math. The square root
of this value here. So the square.
7 is 0.837?
We can sure find out. Let's find out. Must be. See, square root of 0.7 equals square root. There we go. Yeah, 0.837. You doubt my RA.
Doesn't make me feel smart at all.
It's all good. So you want this square root of the AVE to be greater than any correlation with any other factor. If it's not, then it's hard to be confident that those two factors are truly distinct. So the ones we had most trouble with were decision quality and information acquisition. So if we were to go look at the square root of the AVE for decision quality and compare it to its correlation with information acquisition, we can see that we are good. That square root of the AVE is greater than that correlation.
So you're getting.
So that is discriminant.
We are discriminant. We're good. There are a couple errors in our pattern matrix or in our correlation matrix we'll talk about. Let me address this comment. Let's see. It has to be greater than the absolute value, right? Yeah, absolute value. So if you have a negative correlation, then just absolute value that. So in this case, like with this negative 234, we're just looking at the 284, not the negative sign.
What if one of the factors shows up and says correlation is not specified in the model?
Ooh, that means you're missing the covariance arrow in the model. Yeah, if you run this and you have like a triangle star thingy, or a NAAN, or a blank.
So the pattern matrix,
so in the model itself, that means there's probably a correlation missing between those two factors. And if there's not, then there's just some other issue we'll have to troubleshoot.
Saying that for factor on all, but it looks like they have.
Also, don't run it on your CLF model. Okay. Did anyone get it actually installed and run it, and did it work? You just trust me. Good. Okay. Well, now you know how to do it. You're welcome to install the plugin later and check it. But the first thing we need to do, well, the very first thing, I should go back to this. Yesterday, we talked about everything in this first column, data screening. We talked about everything in the second column in EFA. Today we're in this third column. We assume that since we addressed latent measure specification, formative versus reflective factors yesterday in the EFA, we don't have to readdress it during the CFA. But had we not addressed it in EFA, we'd have to make sure we're still using reflective factors if we're in Amos. If we're in a smart PLS or something that can handle partial least squares, we could have formative factors in there. Also, we addressed variable types like nominal, ordinal, and scale, continuous variables yesterday, so we don't really need to address that in the CFA now. We also addressed sample size adequacy yesterday in the EFA, so we can skip past that. So we really start on discriminant validity. We need to address that first. That's addressed, again, by square root of the AVE compared to the correlation, or is the MSV, that's the maximum shared squared variance, is it greater, or is it less than the AVE? This is what this all means. The maximum shared squared variance, let me put the up arrow here, is which correlation is the greatest and squared. So if we look at useful and we look at all these correlations, which one is the greatest? And is this correlation more than or less than the AVE for that factor?
The AVE or the square root of the AVE?
Just the AVE itself, yeah. So we were just comparing correlations to AVEs in this case. In this case, like with usefulness, the highest shared variance is 0.312. You can go find that. That was with useful. 0.312, if you were to square 0.56, you get 0.312 probably. And then that is less than the average loading. What does this even mean? What this means is the variance in the usefulness factor is more explained by its own items than by a correlation with some other factor, the items of another factor. Therefore, it is distinct from other factors. Because this maximum shared squared variance is just the amount of variance it shares with another factor. So if another factor shares more variance with it than its own items explain, then you have a problem. Okay, so that's discriminant validity. There are other approaches to discriminant validity. A really weak approach is just to look at the correlations and make sure nothing's above like 0.7. Another approach would be the HTMT, heterotrait monotrait approach. Amos doesn't produce that. I'm working on a plugin right now that will produce it, but I don't have it yet. But usually this is sufficient. Square root of the AV compared to the correlations. Yeah?
So if you're writing up validity, you wouldn't want to just say AV is greater than the maximum shared variance.
You could do that. You could definitely do that. And then you could augment that with the square root of the AV on the correlations, which is a Fornell-Larker criterion, is what it's called.
The square root of
the AVE compared to the correlations. Yeah. Or the MSV compared to the AVE. So
for some reason it's validity.
it's not working, so we'll have to troubleshoot that offline. You'll notice in this plugin, it gives you some output, the concerns. There are no discriminant validity concerns. So we're good. If there were, it would have highlighted them in red. The next step is to look at convergent validity. The order does matter because you want to separate factors before you start worrying about how tight they are. So we look at convergent validity, which is to see if the AVE is greater than 0.5. And in all cases, the AVE is greater than 0.5, except for social desirability down here. But again, we're not terribly concerned about social desirability since it's just a specific bias construct. So we're pretty good. You can also, if there is an issue, it'll bring it up here. As you see, convergent validity, the AVE for this is less than 5, and it'll give you a recommendation. Try removing social desirability 4 to improve at the AVE. You'll notice if you go back here, social desirability 4 is going to be the lowest loading item. It's 0.48, whereas the other is a little higher. So it just makes a recommendation based on that. If we were to remove social desirability 4, the AVE would rise because the average loading would rise. Okay. Once we've done convergent validity, and all you'd report in that is all AVEs greater than 0.5. That's it. One sentence in your output. Then we look at factor reliability, which is, you're good.
So not standard loadings were greater than 0.5, but
well, that's important that those standardized loadings are greater than 0.5, roughly. but it's the AVE we're really concerned with. Is the AVE greater than 0.5? For reliability, for the EFA we use Cronbach's alpha. For the CFA we use composite reliability, which is an updated measure that takes into account error. So the CR is calculated for you. In this plugin, it's not calculated in Amos. But the CR has got to be greater than 0.7. And in all cases, we're good here, except for social desirability. And in these cases, it's going to give you the same recommendation probably. Yep, remove social desirability 4 for this one, because reliability is going to be improved when AVE is improved. There is, I wonder if I put it in here. No, I didn't. There is an article out there, there are a couple articles out there that say that AVE is a little strict. It's a pretty strict measure of convergent validity, and that you could establish convergent validity and reliability based on the CR alone. There's a citation for that. It's on the StatWiki. It's Malhotra and Dash. Let me see. StatWiki. It's in the CFA. Control F dash. There we go. It explains it right here. It gives the reference and gives their quote and what page that's on. So if you're really close, but you just can't get that AVE up, but the CR is good, here's a citation for you. Okay.
Can you just briefly comment on what does it mean for a construct to be reliable? So I understand validity.
Yeah.
But reliable.
Reliable is the error consistent? Are the items loading together consistently? It's a measure of consistency. If we were to rerun this, are they going to load the same way? That's reliability. Convergent validity, on the other hand, is are they loading highly? Are those loading strong? And then discriminant validity is how far apart are these factors? Are they cross-loading or not? Good. Feel free to stop me anytime, ask questions. This all makes sense in my head, but this is like the 9th boot camp I've given. So stop me if I say something that just doesn't compute. And it won't be a stupid question because this is structural equation modeling. It's not a simple topic. So there are no stupid questions. All right, somebody had a question on the chat. Can you show how to load the CFA file again in Amos? Yeah, sure. If you want to open up this model, the .amw file from the Google Drive, you can just go to File, Open, and it'll search automatically for AMW files, which in this case would be this CFA initial. And it would be in your downloads folder probably. And it reset mine. Nice. Let's see. Where'd you go? Mine disappeared. Nice. Let's go back to this one. There we go. Okay. So that's convergent discriminant validity. If you did not meet discriminant validity, let's go over to here. If you did not meet discriminant validity, what can you do about it? What I would do, first off, you should meet discriminant validity because you did it in the EFA already. And if you did it in the EFA, it's probably not going to show up in the CFA. But for some reason, maybe it will. And how would you address that? Person on chat, let's see. Oh, thank you, good. Okay, the way you address it, let's pretend for a moment that it was decision quality and information acquisition. They're the closest two factors. What I would do is I would go back to the EFA. Don't do this with me, just watch this part. I would go back to the EFA and I would run a factor analysis with just the items from those two factors included. So in this case, we didn't include in the final EFA decision quality 6, 11, or 13, so I'd still exclude them now. I just include the factors that we included in the final CFA, or in the CFA. But in this case, I would run, just as we did yesterday, I would run a factor analysis where I force it to 2 factors. Right here, force it to 2 factors. And I would make sure in my rotation that I'm viewing a loadings plot so that I could see it visually and separate them visually. So if I go all the way to the bottom here, I'd look at this loadings plot and see how they're loading together, and I'd see, in this case, we already have discriminant validity, so it's not an issue, but let's pretend we didn't have discriminant validity. I would see, here's this one, decision quality 12. This one is the closest overlap. It's the closest connector that's not keeping them separate. And so I might go and delete decision quality 12 and see if that works. I go to factor analysis, delete decision quality 12, run it again, and we'd see how far apart we are. Now they're nice and distinct from each other. We can go up to the pattern matrix and see, no cross loadings at all.
Distinct is they're culminating around the axis.
They are separated. Yeah, one's a Y, one they're is that called orthogonal to each other, right? They're loading totally separate. And then what I do is I go back to my CFA and I would take out any items that I took out during that separate EFA. So here's decision quality 12. I would just delete this one and then rerun my CFA and hope it works. Now the question is, we just changed our CFA. Do we have to go back to our full EFA and rerun that and re-report that? The answer is no. We're done with the EFA. Don't have to go back to that at all. We've already validated our EFA. It works. We were just using it as a tool, in this case, to re-distinguish two factors.
It's telling you that your AVE is 0.497.
Oh, that's so close.
And it says if you release this item, you would get the AVE. Do I care at that point?
If 197, I would just keep it all together. Unless you had like 12 items on that factor.
To give up an item if it's that close.
If it's that close, yeah. But also it depends on how many items that factor has. If that factor has more than 6 items, man, just lop one off. In fact, if it has more than 4 items, I'd just lop it off.
All right, so 3.
All right, if it has 3, definitely keep it. In fact, when you have fewer items, you're able to accept a lower threshold for AVE and CR. So, yeah, especially 3 items. 3 items is pretty iffy in Amos. 2 items is really iffy and often will create problems. 4 is ideal. Okay. Someone had a question on chat. Let's see, can you show how to run again that EFA? Do you mean the EFA, Michael? Yes, okay. So yeah, what I do is if it were 2 factors in Amos that were not showing discriminants as indicated by this correlation matrix, for example, if the decision quality and information acquisition correlation was like, was above 0.725, then I would take just those 2 factors items over in SPSS and only use those 2 factors items. In this case, we also had decision quality 12. I should add that back in. I just use the items from the CFA for those 2 factors. So we could go look at it and figure out what those items were. They're right here. And then I would force that EFA in the extraction button. I would force the EFA to 2 factors instead of using eigenvalues. I'd use fixed number of factors, force it to 2, and then I'd make sure in the rotation that I use a loadings plot because that'll create a visual for me. And then when we run it, you'd get this plot at the very bottom to show you how far apart they are. Anything that was sort of bridging them, I would delete that bridge, 1 item at a time. Okay. Oh, no. I opened up another program. Close that. No. Okay. All right.
When you work around the CFA and Amos, can you go back to the output?
Yeah.
What you have clicked there in the outputs?
This or the?
No, in the text.
Oh, yeah. This one?
Yeah.
Or the actual output
When I
file?
run the output, I'm not getting that. Or when I run the model, I'm not getting that.
Yeah. This is only when you run the plugin. Yeah. The Validity Master plugin. What you'll actually get, let me show you what you actually get when you run Amos without the plugin. You can click on this report button next to the save button. If you click on this report button, then either a report will pop up, or it will hide because it's shy. There it is. I don't know why it does that. It's just another bug they haven't fixed in Amos. It's back there. It's the purple icon. And if you can't find it, you can also look down in your icons below and then be like, oh, there it is. Click on that. But this is what actually is produced by Amos. And I can show you, let's see, if I just, there are many different sections. Let me change a few things here to make this more visible to everybody. Okay. So there are several sections. The analysis summary, you don't ever really need to worry about. Notes for the group, sometimes if there are errors, you can look at that. Notes for the model, also, sometimes it'll show you errors here. You can troubleshoot there. But estimates is really what we're interested in. But what it produces is just all this output, and none of it's organized in a manner that's useful. I don't know why they wouldn't. It's standard for statistics software. They just give you a dump of estimates and never interpret it for you, never organize it properly for you. I don't know why. So here we go. Let's look through each one. If I open up estimates, you can see there are scalars, which will open up. There are regression weights. These are unstandardized regression weights, but they provide p-values for you, whereas the standardized regression weights, they don't provide a p-value, but these p-values are relevant to those standardized weights as well. We should have significant p-values on all of our estimates because these are just indicator loadings from our reflective factors. So they should all be significant. Here are the standardized regression weights. These are the loadings. These should match pretty well what you saw in your EFA. So for example, if we go look at our EFA, for usefulness 1 loaded at 0.818 and usefulness 2, 884. If I go look at the pattern matrix, back up here, wherever we produced it, nope, not that one, this one, and go look at usefulness 1 and 2, 846 and 808, pretty close. There are different constraints in a CFA than in an EFA. EFA is pretty much unconstrained. CFA, we're saying that these 7 items belong together, and so we're constraining it. So the loadings will be slightly different because of those parameter constraints. But they'll be pretty darn close to the EFA. Also, covariances, pretty much ignore that table for now. There are other things you can do with it, but we won't do anything with it. Correlations, which we saw in our correlation matrix, but organized in a terribly unuseful table. Why wouldn't you put correlations in a matrix? And then variances, which we won't use unless we need to troubleshoot. So that's convergent validity, discriminant validity, and reliability. What do you report? You report, we ran a CFA and observed discriminant validity, all, you put in parentheses or colon or something like that, all square roots of the AVE were greater than interfactor correlations, all AVEs were greater than MSVs, period. We observed convergent validity, all AVEs were greater than 0.5, and we observed composite, we observed factor reliability, all CRs were greater than 0.7. And that's it. 3 lines.
Is factor reliability and scale reliability?
Yeah. For those who didn't hear that remotely, factor reliability, scale reliability, construct reliability, composite reliability, those are all the same thing. Okay, we just burned through that. The last, not the last, the next thing in a CFA is measurement model fit, which we haven't really talked about until so far. So model fit needs some explanation, and I should maybe show a slide for that. I'm going to jump over to these slides, make sure I haven't missed anything huge. Talked about that, and that, and that, and model fit. So model fit is, the question it's answering is, to what extent are we accounting for all major relationships in the model? Are there relationships that we should be accounting for that we're not accounting for? Is the way we specify the model the best way, or at least a good enough way that we can have confidence in the estimates we're generating? Because if we're modeling the variables with relationships that don't make sense, that don't match reality, or at least the reality we observe in our covariance matrix, then we can't be confident in the estimates it's producing, because we might be missing some major relationship that would confound the estimates that we are producing. So in a measurement model, it means, are the items belonging to the right factor? For example, this one here, Q38, does it really belong to absorptive capacity, or should it really belong to mindfulness? We've modeled it this way, where it belongs to absorptive capacity, but if it would better belong to mindfulness, then we'll have lower model fit. So that's what it means in an EFA. In a structural model, a causal model, it means, are we accounting for all the major relationships, the causal relationships? For example, this relationship between usefulness and decision quality is not accounted for. Therefore, can we rely on these ones that are accounted for? No, we can't unless we have good model fit. Notice when we include the relationship between usefulness and decision quality, a couple things happen. First off, the R square, the variance explained in the dependent variable, jumps from 7% to 31%. That's a huge difference. And the effect from frequency, which was 0.27, drops dramatically to 0.11. So had we reported the relationship between frequency and decision quality is significant, but model fit is bad, we would have no confidence in that hypothesis test at all. But in this other model over here, we could say model fit is good, and there is no relationship between frequency and decision quality, at least probably not a significant one. So that's why we do that. It's also good for testing alternative models. We can model these in different ways. Which model has the best fit? Whichever one has the best fit is probably the best model, because it best represents the natural correlations in the data. But we don't want to overspecify. So looking at these two models, the one on the left is going to have better model fit because we're accounting for more relationships. The one on the right is going to have worse model fit, but it might still be a good model. If both have adequate model fit, I'd prefer the one on the right because it's simpler, more parsimonious. The way model fit's calculated is fairly straightforward. You take the covariance matrix that is built into the data. It's just, this column and this column, to what extent are they related? And you take the covariance matrix that includes all of the variables you've included in the model, and then you subtract from that the covariance matrix that you've implied by the way you've modeled the data. Because we have a new covariance matrix that is implied by the way we model, all the parameters we specify. So in the case of this model, we're not correlating every item with every item. We're saying these items correlate together, and as a whole, they correlate with other factors. But the weighting is definitely within each factor. And so we're emphasizing certain correlations. And when you subtract that covariance matrix from the real observed covariance matrix, the difference, literally just the subtraction, the result of that subtraction is the chi-square. And as the chi-square gets bigger, you have worse fit because you're not accounting for as many relationships as you could account for. So as chi-square increases, model fit gets worse. And that's how chi-square is calculated. That's how model fit's calculated. And so you want the implied model to match the observed model as best as it can while still being parsimonious, still being as simple as possible. I often get asked, is there a maximum threshold for chi-square? That we should not have a model that has a chi-square above this amount? The answer is no, because it totally depends on sample size and number of variables, model complexity. I've seen chi-squares I was doing a paper with Richard Boyatzis. He had like 26,000 sample size, and we had like 80 variables in our model, and the chi-square was in the hundreds of thousands. So whereas other chi-squares, like this one you can see here, 75. Is one better than the other? Depends on the model. So no, there's no absolute maximum threshold. But if you were to divide the chi-square by the degrees of freedom, you'd have a pretty good idea of a relative chi-square. And you want that to be between about 1 and 3. Degrees of freedom, I should explain. You've used this your whole life since stats in high school, and you maybe have never understood what it means, maybe. I never did until like several years ago when I started doing these things. Degrees of freedom are just the paths or the relationships you could have accounted for, but you didn't. So I wonder if I have back here, in this model here, there are 3 possible relationships we could account for. We are not accounting for one of them. Therefore, we have 1 degree of freedom. That's how it's calculated. That's it. That's degrees of freedom. The parameters you could have included but didn't. So the one on the right here has more degrees of freedom than the one on the left. The one on the left has 0.
So high degrees
No,
of freedom.
2, 3. Has 3 degrees of freedom.
So if you have high degrees of freedom, you may have a more parsimonious model.
Correct. The more degree. Well, the thing is, so degrees of freedom is often the denominator in model fit assessment, which means the higher the degrees of freedom, the better the fit measure, the lower the fit measure, depending on which one. Parsimony being important. More degrees of freedom is better if you can still hit model fit. Now, so the one on the right here has lots of degrees of freedom. 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 degrees of freedom that I can see. So it's better if it has good model fit. There are lots of model fit metrics. I'll show you several, but here's a table of many. Do you need to report them all? No. Some of them are somewhat outdated, like the GFI and the AGFI. The most common ones to report, it probably depends on journal and field, actually. In my field, the most common ones to report are CFI, SRMR, RMSEA, and PCLOS. But in your field, it might be the NFI or the TLI or who knows what. And I don't even have those listed here. What could cause poor fit? If you don't do, excuse me, poor fit could be if you missed stuff on the left here. If you skipped data screening, then you might have variables that have a bunch of outliers or might have non-normality or something like that, and that can warp your chi-square, it can inflate your chi-square. If you have formative factors that should be reflective or reflective that should be formative, then that could inflate the chi-square. All those things on the left. If you don't have convergent or discriminant validity, that can inflate the chi-square. So do all your pre-work before you get to this point. Remedies, we'll talk about this when we get into the software. And then we're there. Okay, so that's model fit. You need to assess model fit. And as soon as we do that, we're going to take a break. In Amos, the way to assess model fit, I'll show you a plugin, but you can also just look at the output. Here's the plugin for it, model fit measures. Does your model have missing data? No. Okay, it's going to run. It's going to produce a pretty table. Here's the model fit. It gives you several of the relevant ones, the published threshold, and whether yours is acceptable, excellent, or terrible. Here are those thresholds for acceptable, excellent, and terrible. It looks like we have pretty good fit everywhere, including we have acceptable on the CFI. And here's a citation for where those come from. But you can also look at this in the Amos output, just in that output window. There's a little section down here called model fit. So you click on that, and you get all, whoa, too close. You get all these measures. C-min is another way to say chi-square. You can also say chi-square as x squared or chi dash square. So lots of different ways to say it, but C-min is one way to say it. This is the C-min over DF, degrees of freedom. It should be between 1 and 3. I skip the RMR because I use a standardized RMR. And I also skip the GFI, although some journals still like you to report GFI, but it's somewhat outdated. The CFI is commonly reported. It should be above 0.9, ideally above 0.95, but 0.9 is fine. And then there are a bunch more measures, bunch more. Let's go down to RMSEA. This RMSEA, you want this value less than, I think is about 0.05, although they're published metrics all the way up to 0.1. So pick
Why
your.
would you not get like a GFI show up in your model fit?
If you, yeah, so GFI won't calculate if you're not estimating standardized estimates. So you have to check the box for standardized estimates. That's probably the only reason GFI wouldn't show up, I think. Yeah. Anyway, tons of things to remember. That's why we make videos and tables, and you can just refer back to those. That's why I make plugins, so you don't have to remember what's the threshold for SRMR. Or, yeah, it's all right here. If you were to calculate SRMR, notice it wasn't in the output. You have to do that manually, sort of manually. You go to plugins, and you have this built in. Standardized RMR is right there. This isn't mine, this is Amos's, so it's already built into Amos. You should have this plugin. You just click on that, and this window pops up with nothing in it. It should say run the model, but it doesn't. So while it's open, run the model. And then it produces its value right there. So that's standardized RMR. So
Now, can we also get that if we use the model fit plugin?
yeah, the model fit plugin produces the SRMR right here.
So we don't have to.
You don't even have to check that. Yeah. So recap. Why do we bother with model fit? The reason we bother with model fit is if our model doesn't fit the data, then we haven't specified our model correctly or in a correct enough way that we can have any confidence in the estimates that it's producing. Even if it produces nice estimates and it looks valid in every single way, if the model fit is bad, that's telling us that there's a better way to model the variables in our model. So we better do that. Yeah.
So we did the EFA to see how it fit within the factors.
Yep.
Right.
Totally unconstrained. Let it figure it out itself.
So then, okay. So I guess I'm just confused on why would it make sense in pattern mixer and it not make sense? How would it not fit this?
Yeah. Why would an item load onto one factor in the EFA, but maybe be more appropriate in another factor in the CFA? The answer is it wouldn't. That wouldn't happen. Okay. Typically, if it worked in the EFA, it's going to work in the CFA.
But you still have to do a CFA.
But you still have to check it. Yeah. So the CFA is kind of handy because you can check model fit and you can check composite reliability and you can check other things like method bias, which you can't do in an EFA, not properly at least, and invariance, which we haven't talked about. So things you can do in the CFA that you just can't do in the EFA. Okay. Yeah. So that's why you do it. But there are things you can do in the EFA you can't do in a CFA, like have a totally unguided factor analysis, which helps reveal discriminant validity issues that would maybe be hidden in the CFA. So I often have people email me and say, hey, my CFA, I ended up deleting like 20 items from my CFA, and now I only have 2 items left on each factor, and I just can't get the thresholds right. I can't hit the model fit. And I ask them, what did you do in EFA? Well, no, these are all established factors. I don't need to do an EFA. But if they go back and do their EFA, they'll figure out a much better way to model the data. Yeah. So both are very important. All right, there was a chat question. How do I get to the red arrow being available and show numbers? Oh, yeah, good question. Not super intuitive. In Amos, to get that red arrow to be able to show stuff, you need to run the model, calculate estimates. It's this button right here next to the colored abacus above the save floppy disk. So you run that. After you run it, the red arrow should become available. And when you click on that, you should see estimates over here. By default, they'll be unstandardized, and so you'd have to check the box, or you have to highlight standardized here. Click on that instead, and then it'll show you standardized estimates. Hope that helped. Okay, let's do this. Let's take a 5-minute break, and we'll get back. There is one more thing I want to say about model fit. 2 more things I want to say about model fit, but then we'll move on to other stuff. Yeah. Yeah, during the break, I'll come see you. We're making fabulous time. I think we're going to finish most of CFA before lunch, which is exciting because that was supposed to be the whole day. We'll start on tomorrow's content. And then maybe some of you won't have to show up tomorrow if you're not interested in PLS. Remote folks, I'm going to pause this. I'm going to pause the recording and remind me to start recording when we get back. All right, we're back up and running. There were a couple things we need to discuss. I was thinking about during the break. The first is I didn't talk about the chi-square p-value. So you'll notice when you run a model, in the notes for the model, let me zoom in the notes for the model, also in the model fit section, you'll have the chi-square and the degrees of freedom and a probability level. There's a p-value for the chi-square. Is this chi-square too big is the question, essentially. This used to be used as a model fit measure, but it's not a good one because the chi-square is so sensitive to model complexity and sample size. And so, I mean, the ideal number here for your p-value is not significant. You want more than 0.05, which seems backwards, but it's just trust me on that one. Sometimes we like p-values more than 0.05. Sometimes we like p-values less than 0.05. It depends on what the null hypothesis is. The null hypothesis here is that there is no difference between your model and the proposed and the observed model. So we want there to not be a difference. We want them to match. If there was a significant p-value here, that means we would reject that hypothesis, the null hypothesis that there is no difference, which means there would be a difference, which means the model fit wouldn't be great. So that's why we want greater than 0.05. So anyway, that's not a good measure of fit.
So yours is not greater than 0.05, but you don't care.
Don't care. Because
mine wasn't greater than 0.05.
I have only occasionally seen a greater than 0.05 there, and it's when you like over constrain the model and reduce the chi-square to something super small. So don't worry about that one. And if a reviewer says, but what about the chi-square p-value? Tell them they're an idiot. Not in those words. Tell them that there are more updated measures that you could use to provide better evidence of rigorous statistics. Yeah. Okay. Was there one other thing? Oh, there was. Let's say you don't have good model fit. Just pretend. What you could do is check this box in the output, the analysis properties. Click on that colored abacus, pops up this window, and in the output tab, there is a box down here for modification indices. There's also one for residual moments. You may want to click on that. And there's a threshold here for how big of a modification you want displayed. This, again, depends on your chi-square. If it's really big, you want a big number here. If it's really small, small number here. We have a moderately sized chi-square. I'm going to put in 20 here. How did I get that? Experience. 20 is good. Unless we had very small model, very small sample size, then it'd be like 4. If we had really, really big, I might put in 200. So fiddle with it. Okay, check that box. Run this again. And look at the output. It's hiding. There it is. And if we look, there is a new section here called modification indices. If you click there, it will show you all the modification indices over the threshold I specified, which was 20. A modification indice is the extent to which the chi-square might change if you were to account for the parameter you're not currently accounting for. In this case, it says there are a bunch of errors you could covary, which isn't good practice. Don't covary errors, but it implies something. So if we look at the highest one here, 56, it says error 19 and 20 are highly related. If you accounted for that relationship, then that part of the difference between the two covariance matrices would be accounted for, and the chi-square would drop. So your model fit would be better. But let's go look at what that really means. Let's go look at the model. It was 19 and 20, which if we zoom in, 19 and 20 are for playful 5 and playful 6. Well, playful 5 is worded, oh, no label. I can go back to the SPSS file. Go look at playful 5 and 6. Here they are, right here. These were back-to-back in the survey. I am inventive when I interact with Excel. I am creative when I interact with Excel. How do you think they answer these two questions? Identical. They probably just put, yeah, 4, 4, whatever. And they'd already answered multiple other questions about spontaneity, imaginativeness, playfulness, flexibility. They're all saying the same thing. So yeah, same, right? And so it's just through systematic, their position in the survey and their wording, they're highly correlated. So they have a systematic error correlation. So how do we account for that? If we needed to fix our model fit, I might go in here and say, well, we don't need them both. We have 7 items on this reflective factor. We only need 4. So these are highly redundant.
Recording this right now?
Yeah, oh, dang it, am I recording?
I'm not sure.
Yep, I'm recording. Woohoo! Thank you for the reminder. But yeah, I'm recording. So what you could do is say, well, 5 and 6 are redundant with each other. I don't need them both. And by deleting one of them, I can get rid of that missing parameter, the parameter I'm not accounting for that's inflating the chi-square. So if I were to delete this, and just watch, don't actually do this. Let me save. Excuse me. And I'll delete. Let's see if I hit the up arrow, which one has the worst loading. Let's see, 6 is 7 or 87, 85. So I'll get rid of 5. So playful 5, you're out of the family. Get rid of you. And if I run this again, you'll see my model fit will have improved. My CFI will have increased. Whereas before my CFI was what, 0.927, I think. The CFI is now, if I go look at the model fit, CFI is now 933. So it improved. I could go through and do this and find all the biggest modification indices and address those, and that would increase my CFI. It would improve my model fit. Question though is, at what point do you just say enough is enough? I have good enough model fit. Good enough is the right way to think of it. You don't want to optimize model fit. I could optimize by going and addressing every single one of these modification indices, but that's overkill. I just need to have good enough model fit that I have confidence in the way I've modeled my variables. So good enough is, good enough is when you see these tables, if you've met acceptable thresholds. If something's terrible, you haven't hit acceptable thresholds. So fix that. But if you're at acceptable, even if you're not at excellent, you're good enough. And so don't keep modifying your model. Just as a warning, I mentioned this in passing, but I want to show you, do not covary errors to account for modification indices. It's not good practice. You can do it and it runs and it fixes the problem, but it's really like a Band-Aid. It's not fixing the underlying problem. It's just essentially removing that piece of the chi-square inflation. So don't do that. It's not natural. So don't. Yeah, that's model fit. Okay, let me go back to the model that we were working on. Let's see, this one. No, don't save. There we go, okay. So now that we have confidence in our model, the way we've modeled it, and we know that the factors are all valid and reliable, the next thing to do is determine if we need to do an invariance test. Invariance is our...
Jane?
Yes?
Can you please explain what you have just said about not to covariate the errors? Because then the Amos says we need to do that.
Yeah, in the modification indices, let me show them again. I have to run this. Let's see. It's running. I gotta check the box just a sec. Modification indices, and let's bump this up to 40, sure. Oh, I didn't tell you about residual moments. Whoops, I'll have to show you that in a sec. So I run this, and look at the output. The modification indices says, well, if you would just covary these two errors, then it would fix the problem. So it's telling you to covary them, but you shouldn't covary them because it's unnatural. Like you can, if you go back to like when you'd have to calculate a structural equation model by generating the formula to do it, which was a while ago, the piece of math you'd have to add to the SEM would be so unnatural, it's just wrong. It can work, but it's wrong. So we don't covary errors. It's better to just delete one of the items associated with those errors if we have extra items. Or if we have good enough model fit, just leave it. Like our model fit's good enough, 0.929, that's fine. We don't need a 0.95, we're fine.
So you wouldn't even consult the modification indices if you're content with your model?
Yeah, if our model fit is good, I wouldn't even look at modification indices. Yeah. Notice one more thing I didn't show you. Here it is. The output makes recommendations. Oh, it doesn't in this case. Let me mess up our model fit real quick. Let's go like this. Let's have some fun. And yeah, hopefully that'll mess things up. We'll see. Let me run this. Plugins, let's see, model fit. What I'm trying to do is show you what happens if you have bad model fit, what the plugin will give you. Your model fit could improve. Look, my CFI is terrible. Based on standardized residual covariances, we recommend removing social desirability 10. So it turns out social desirability 10 is most related to most other items. If I were to go look at these in the output, there is something called, it's in the estimates matrices. There is this awesome matrix, standardized residual covariances, that tells you to what extent is every variable, is the relationship between every variable inflating the chi-square because of this relationship with every other variable. If I were to copy this, let's see, it doesn't want me to copy. Right here, click, copy. And just go put this over in Excel real quick. I've created a little tool that'll tell you which one's causing the most problems. It's called fit check. Fit check. Oh, reset. Is there a reset button? Tell me there's a reset button. There's a reset. Phew. So if you were to paste that whole matrix in here, it'll tell you anxiety 4 is the biggest problem. Problem is, we don't want to delete anxiety 4 for some reason. I wonder why it's giving me social desirability 10. Now I'm confused. Uh-oh. Well, anxiety 4. Huh, interesting. I wasn't expecting that. Well, anyway, what this does is it tells you which variable is most related to every other variable. In this case, it says anxiety 4. Oh, it's because it doesn't want me to delete. Here's why. It doesn't want me to delete social desirability 10 because there are only 4 items on there, and I don't want to decrease it down to 3. So it found the next best case, which was anxiety 4. So it says if I delete that one, my model fit will improve because that one's related to so many other variables that it's inflating the chi-square by not being explicitly related with arrows to all those variables. So if you would delete that item, the chi-square would deflate and your model fit would improve, which I can show you to decrease or get rid of anxiety 4, run this, and our model fit should vastly improve. Should have just used the plugin. Whoops. Okay, plugin model fit. Anyway, so you can use that table, the standardized residual covariances, or just the output of the model fit plugin to determine if another variable could be removed to make things better. So it did improve a little bit from 8, whatever it was before, 824 all the way up to 879. That was a pretty big jump just by deleting one item. Anyway, that's standardized residual covariances. Well, let me go back to a real model. Any questions about model fit before we move off of model fit?
You keep looking at CFI.
Yeah.
You don't report it.
Oh, I would report it. Yeah. That in your you mean the model fit?
Okay, yeah, that's
Yeah.
right.
CFI's there. Yeah.
Okay, good.
And what would I put in my report? I would just literally copy and paste this table and put that in my report, and then cite this guy down here, Who and Bentler. Yeah. I'm missing a covariant or parenthesis.
Should we include congratulations, your model fit is excellent? Can we put it in the report?
You know, I've actually reviewed papers before that have used my Excel tools here, and there is in the Validity Master, if you don't have any validity concerns, it says no validity concerns, wahoo, exclamation point. I've seen that phrase in papers I have reviewed. Yeah, and I just laugh and leave it. It's great. Yeah, like sweet, someone's using my tools. These tools, by the way, Excel tools, they're available on the StatWiki, just on the homepage, if you wanted to download that. Most of my plugins cover the need for the Excel tools. Make it redundant. Any other questions about model fit? Okay. Yeah.
The variance inflation factor.
VIF, yeah.
Related tolerance. Can you go over those?
So VIF and related tolerance, those are topics of multivariate issues like multicollinearity, which we'll talk about in our causal modeling. Yeah, so not super relevant to the CFA unless you're doing a formative factor analysis, in which case VIF is highly relevant. So in that case, we'll cover it tomorrow during PLS. Yeah. Any other questions about model fit?
Yes, please.
Yes.
So do we have to do this before any causal modeling?
Heck yes. So here's why. So the reason you have to do a CFA, if you have reflective latent factors. If you don't have reflective factors, then no, you don't have to do this because a CFA is irrelevant to non-latent factors. Like if you just have averages or calculated values, single item variables, you don't need to use the CFA. It's only for reflective factors. But if you do have reflective factors, you definitely need to do it, because if you don't do it, we don't have any confidence that the way you created those factors and the way they are modeled is actually a good representation of the relationships in the data. And so then if you were to go and produce some sort of regression between, in this case, let's see, a regression between playful and decision quality, we couldn't have any confidence that what we were actually viewing in our estimate was a relationship between playfulness and decision quality, because we haven't established that the way we've modeled those two variables is appropriate.
But can you explain more what is considered a latent variable?
Yeah, latent variable is any variable that has multiple items. Like in this case, playfulness has 7 items. Playful here is the latent factor, not directly measured by anything. It's indirectly measured by these 7 things. Whereas if I were to use, let me go down to the bottom of my data set here. If I were to use instead something like age is not latent because it has a single score, it is observed, it's not indicated by multiple indicators, it's just one thing. Same with education, it's one thing. And experience, gender, frequency, these are all one thing, they're not latent at all. Revenue, income, sales performance, those are all not latent. So they wouldn't belong in a CFA.
What I usually use is I take a scale and I just compute the subscales, and then I compute a total scale, and then I use it in Amos. So you're saying that everything that I'm doing is wrong? Everything you know is wrong.
No. The practice, sorry, the practice that we used to engage in during first generation statistics was to do that approach exactly. You look at a scale, maybe calculate its Cronbach's alpha, and then create an average for it. But that can bias your data, bias your results, and undermine your confidence in any relationships you do observe. So the most rigorous approach is what I'm showing you. And most high rigor journals will require, if you have latent factors, they'll require you to do a CFA.
So I will need to take only the scales with subscales and do this.
Correct, yeah. If you have a bunch of subscales, you'd want to run an EFA, a CFA, make sure they're all valid and specified correctly.
And then use it after I modify it in a causal model.
Yeah, and so that's what we'll do after this is we'll take what we learned from our CFA and then bring that into a causal model.
Thank you.
You're welcome. Sorry to rock your world.
I don't know if I'm gonna do all of that. Oh my God.
It's okay. Yeah, it's a big deal. I do this with students all the time. I'm a methodological quant advisor for a lot of dissertations and projects for students. And you go through all this hassle of designing your study and then getting your data, and then you clean your data, and then you screen your data, and then you do an EFA that takes forever, and then you do a CFA and everything that goes into the CFA. And then finally you run your causal model, which takes like 2 minutes. Like that's it. I mean, you run a causal model and you're done. And so you spent months and years leading up to a 5-minute maybe causal modeling exercise, and hopefully you find good results. But you might end up finding nothing, and then you're like, oh, dang.
But you're saying that if I also find good results in the causal model, it doesn't say for sure that it's for the right reason.
Yes, exactly. It all goes back to this. It all goes back to this figure here. Most people jump straight to this box, the local criteria. They just look at the relationships between calculated variables and say, hey, look, regression weight, significant, p-value. Therefore, hypothesis supported. But we have very little confidence in those relationships because we haven't thoroughly validated the measures that went into calculating those variables.
I see.
Yeah. We're learning stuff. This is good.
I see. My muscles are stretching, yes.
Sorry. Yeah. I'm also a believer in doing what needs to be done. If your advisor is cool with whatever you're doing, if you're a student, then keep on rolling. Get that degree. If you are the advisor or the faculty, well then yeah, you have time. So do it the right way.
Yep.
Okay. Somebody asked in the message board. Somebody asked, let's see, what kind of problem is Amos best used for? Amos is really good for a couple things. The confirmatory factor analysis, like we're doing right now, and a causal model, a lot of causal models like mediation, multi-group assessment, just direct path modeling, which we'll do probably after lunch today. So that's what it's best for. It's best also for reflective models, not formative models. It cannot handle formative. It cannot handle formative factors properly. So that's what it's best for. Okay. Anything else on model fit?
Question.
Yeah.
Going back to the flow.
Yeah.
What does MGA stand for?
MGA, multi-group analysis. Yeah. MGA, multi-group analysis, multi-group comparisons. And that's what we'll do next, because we just finished model fit. Any other questions up to this point?
Are we going to do any dyadic analysis?
We will not be doing dyadic analysis.
Why?
What I'm doing here is the critical path for 95% of typical SEM analyses, whereas dyadic analysis isn't part of that critical path. If there is time at the end of the day, can you walk us through inputting all the plugins, please? Yeah, or I'll just send you a video. Carl or Angel, if you're there, you could paste Or actually, here's what you can do. There's a video right here. Plugins info. Here we go. On the StatWiki, there is a whole page devoted to plugins and the folder that they're in and how to install them for different versions of Amos and examples of using them. I will just paste this into the chat window and you can use that. You go. Whoop. Oop, whoops. There we go. Okay. Are we good now to move on? Okay. Now for the most painful part. Because what we've done so far hasn't been painful at all. If you're going to do a multi-group analysis, meaning you have groups in your data that you are theorizing will be different. So for example, in our model, which I don't have there, it's over here. In our model, we have two groups. I think it's gender is what we're using. Let me pull this up. Here's the model right here. We're grouping by gender. We're saying that the relationships in this model might be different based on your gender. And so we have multiple groups in our sample that we're theorizing will be different. Therefore, because we're theorizing they are different, we have to check that they are not different at a measurement level.
When you're theorizing that, is it enough to theorize simply that they're different, or do you need to be specific about how?
So the question for the remote folks, is it enough to just say, our model will be different based on these two groups? Or do we have to say, this group will have stronger estimates or positive, whereas this group will have negative estimates? My preference is definitely you pick a path, pick a hypothesis, and say, this path will be different in this way based on this group. So back to our model here, let me just get myself in trouble real quick. I think the path from playfulness to comprehensive use, let's say, is stronger for females. All right, it's a positive effect. The more playful you are, the more features you're going to use. But I think that effect is going to be even stronger for females than for males. That would be my grouping theory right there. Yep.
So these groups, are they most often gender or maybe like work experience?
Oh, it could be anything. It could be like your job role. Let's say you're dealing with customers, or if you're in the back room, you're dealing with
education level.
Oh yeah, it could be you have college education versus no college at all. It could be you're from this country and not that country. It could be you're young, not old. Whatever. It could be any grouping. Whatever you theorize, and you don't have to use groups in your report or in whatever you're writing up. Only use groups if they're relevant to your theory. One major reason you'd want to use groups is if, let's say we had a model here where we're saying X predicts Y, and we submit it to a journal, and we say, look, our hypothesis is supported, X predicts Y. And the reviewer comes back and says, well, under what context? Like for which type of people? It's totally going to be different for people from this generation than that generation.
So how is a group different than a moderator?
It is. So a group is a moderator because it changes the nature of a relationship. But experience is also moderator because it changes the nature of a relationship. But the way you assess them is different. Maybe I have several slides on that. Let's get to that after lunch today. Yeah. At the measurement level, though, we don't want to see differences. Even if we're theorizing there's differences at the causal level, like between variables, we don't want there to be differences in the way the variables are measured. We want them to be the same across groups. That way we know that playfulness for this group is the same as playfulness for that group. If they're not the same, then we can't say at the causal level that the relationship between playfulness and usefulness is different for these two groups because they're not actually measuring the same thing. So we need to determine that we're measuring the same thing for both groups. And here's where it gets tricky. Let's go ahead and save as multi-groups, CFA, MGA. Yeah, MGA is fine. CFA, MGA. The first thing we have to do is create groups in our data. We have to separate the data set into two groups. The way to do that is up here in Amos, you double click group number 1. And you change the name of this our groups are male and female, where male is 1, female is 2. So male, and then hit new. And it's going to create a new group called group number 2. We're going to call this female. And then hit close. If you accidentally hit new again, you can just go click on the new one you created and hit delete. You just want the 2 groups there. Can you have more than 2 groups? The answer is yes, but when you compare those groups, you need to do them pairwise. Human mind can't actually compare more than 2 things at once. It doesn't work for some reason. You still end up doing things in pairs. Okay, so we now have 2 groups defined, but we haven't given them their data. So back in the data files, right here, select data files. You have to say, oh, where'd you go? Here it is. Here's the male group and the female group. For the male group, we already have data included. So click on grouping variable. And then you're going to jump down to gender. You just click anywhere in there and hit G. And I'll jump down to gender, or whatever your grouping variable is. And then for the group value for this group value, click on 1. Turns out we have a lot more males than females. Is that a problem in our data set? The answer is yes, if the smaller sampled group is below the minimum threshold for having enough sample size. Is 91 enough? Well, let's make a calculation real quick. Let me hit OK on this one. Yesterday we talked about the minimum would be like 3x plus 50. Well, we have 37 variables, or was it 47 variables, something like that, that we're using. Let's pretend it's 50. It's easy math. So 50 plus, times 3 is 150, plus 50 is 200. Dang. So we probably don't have enough to do this properly, but we're going to do it anyway, because we're supposed to do invariance testing. But you might write up in your limitations, only had 97 sample size for the female group, therefore our invariance test might be prone to error or less reliable. But then keep moving on. Okay, for the female group, click on female group and click on file name. Go find the data set again. Same data set. And then you have to give it its grouping variable and grouping value again. So grouping variable is gender. Oh, gender. It is really hard with a big zoomed in cursor. There we go. And grouping value. So I was watching the video last night. It turns out when you zoom in here, the recording doesn't zoom in, which is weird. So the YouTube video won't have it zoomed in for you. Anyway, but when you're done and you've selected the grouping value for female, you should see 287 for the top one, 91 for the bottom one. And now you have your groups defined and data allocated to it. Hit OK. Just so I know what pace to go. Who's actually following click for click? Okay, so I should, okay, how am I doing for pace? We're good? All right, all right. Woo! Okay, we now have data for each group. Just run this model. Just run it with whatever defaults you have right now, just so I can show you something. Show you what it does. Okay, once it runs, and it takes a little longer to run because it's running 2 separate models, or 2 models for 2 separate data sets. If you hit the up arrow, it'll show you the data for whichever model you're currently highlighting. I was highlighting male, now female. You can toggle between them by clicking on male and female up there, and you'll see the estimates on the right change. So for the female group, here are my estimates for playfulness. For my male group, here are my estimates for playfulness. For an invariance test, we have to determine invariance at 3 levels. And I've written those down over here, and they're in the slides. If you were to go to CFA in the StatWiki and go to invariance, you'll see there's configural, metric, and scalar. 3 different invariance tests to make sure we are truly measuring the same thing across groups. There was a question up here on the chat board. Let's see. Sample size needs to be considered for multi-group analysis. Oh, definitely. Yeah. Anytime you're splitting your sample into groups, each group is running the model. And so sample for each group needs to be big enough to run the model. Next question. My dissertation chair had me use G-Power to see if my sample size was okay. Have you used that G-Power? Yes, but I don't typically use it, although you could use it for if you want to like get a quote on something, get a reference. I usually don't report sample size and power unless I don't have enough. Yeah. If you don't know what G-Power is, just Google it. There are tools out there for it, for calculating it. Amos doesn't have a tool for it. Okay, so like I said, there are 3 different types of invariance: configural, metric, and scalar. Configural is pretty straightforward. We'll do them in that order. Configural, we just run the model with the 2 groups. And now that we've separated it, we now have 2 covariance matrices. And so they're going to be different, and the model fit's going to change. We want to make sure the model fit is still good. So we just go to the output, or we could look at our model fit plugin if we wanted. We just click on the model fit and just zoom in here. Let's see. Just check to make sure model fit's still good. Here's our CFI, 0.905. So it's above 0.9. We're good. We go down, look at the RMSEA. Here it is, 0.039. That's good. It's less than 0.05. And our P-close is above 0.05. So that's good. So we're good. We're good. We could run the model fit plugin if we wanted, but we're good for configural. So what do you report? Ran invariance tests. Passed configural invariance test. Model fit was good when model was assessed with both groups unconstrained. Something like that. Really just say pass configural invariance test and they'll know what you're talking about. As long as you knew what you were talking about. Don't just put that in there without doing it. You could, nobody know the difference, but it wouldn't be right. Okay. The next, yes?
Just one question. If that is one of your theories, I guess you elaborate a little bit more.
Yeah, elaborate on what, sorry?
If that is one of your hypothesized models, you say something more than that, or is that just enough?
If it's one of your hypothesized models, I don't think I understand this.
If you say that there's, for example, that one of your hypotheses is that there's no difference between men and women in the model, then you just say that couple of sentences, or you just write something else?
You're saying if in your causal model, you're theorizing no difference?
Yeah.
We have not established that. So we're looking at the measurement model. And in this case, we want no difference. Even if we're theorizing there is a difference in the structural model, we want to see no difference in the measurement model. And so, yeah, in our report for this test that we just did, we'd say there is no difference between men and women using the configural invariance test at the measurement level. Yeah.
Okay, thank you.
You're welcome.
Another question, please.
Yeah.
So the model fit that you just showed,
Yeah.
does it say that, to which model is it, the model fit? Is it for the males or the females?
So there's really only one model, and it is that model. We're just assessing it from 2 different angles. So the model fit will be the same for male and for female, because it's not model fit for male and female, it's model fit for the model, not for the data. I know that's a little confusing.
It doesn't use each time the separate M, the sample size?
Correct. Correct. It's assessing. It's assessing the. Sorry. Go ahead.
It uses the whole 300 and something.
So what it does is it runs the same model twice, once for each data set, and it comes up with a covariance matrix for both, and it compares that to the observed covariance matrix to see if it is modeled properly when separated into groups.
So it is comparing between males and females.
It is, but it's the same model. Therefore, the model fits the same for either because it's being assessed with both separated. That was not confusing. Essentially, what we're trying to assess is when we look at the data separated by gender, is the way the variables are specified, is it still a good way to specify these relationships between variables? If it is, then it's okay to separate by male and female. If it turns out that this is a terrible way if model fit's bad, that means that male and female are not good groups to separate the data by, because they're so different in terms of how they understood the survey questions and the way they answered them.
I was just wondering, can we compare them?
Can we compare male and female? In terms of model fit, no, because it's one model, but we compare their estimates. We can look at the regression weights here. In fact, if you go to the output, it's even easier. If you go to the output, go to the estimates area, scalars, and then click on, let's say, standardized regression weights so that it is highlighted. You can then see down below, way down here, there's male and female toggle, which you can toggle between, and it changes those estimates on the right. Let me pull this over a little bit. So you can see when I toggle between these, then we can compare. The regression weights are different between male and female. But again, the model fit, I'll show you if I go to model fit, it's just one model. And so I can't toggle between male and female because it's just one model. There is no difference between the models. They're identical. That's not super intuitive. Invariance isn't super intuitive. If it doesn't click the first time, then you're a lot like me. It might take several times for it to click. Or I'm just terrible at explaining it. That could definitely be the case.
Dr. Gaskin?
Yeah.
I have a question under the Amos output, the assessment of normality. The variables are listed on the left, and it says minimum and maximum of 1 and 5. What does the 1 through 5 mean?
Assessment of normality?
Yeah, it says, or I clicked on the assessment of normality for group number 1. I'm just not sure what it says, minimum and maximum 1 to 5. Is that automatically in there?
I'm looking for that. Is that in the output?
Yeah, it's on the output in the variable summary, under the variable summary.
Oh, variable summary. Oh, I never look at the variable summary. Let's see if I can open that up a bit. And you're looking at normality. Let's see.
It's under parameter summary. It says.
Oh, parameter summary. There we go.
Sorry.
Parameter summary, male. And you're looking at what aspect of this?
I didn't put in the data that you guys had. I just was wondering. It says minimum of 1 point and then 5 point for the maximum. I wasn't sure what that was.
Minimum. I'm gonna have to turn you up. I can't hear you well enough. Sorry. Minimum of what?
It says minimum is 1.000 and a maximum of 5.00 in the assessment of normality for group number 1.
I'm not sure what that refers to. But in Amos, often you can click on something, not this thing apparently, and it'll link to it'll link to the help file. Let's see if I press F1 on this if it'll do anything. Nope. Often if you hover over something and it becomes a link, you can click on it and it will give you more information.
Oh, I got it. Thank you.
Oh, excellent. Whew. Okay. Here we go.
Another question, please.
Yes?
So let's say after you divided it into males and females, and then you run the model, and then the model fit is not okay, then would you go to the estimates and like try deleting arrows?
Oh, that's a good question. Yeah. So if the model fit wasn't good at that point, what would you do? Yeah, what I would do is I would go look at the estimates, the standardized, well, I'd look at the unstandardized regression weights, and I'd make a comparison between them, between males and females, and I'd see which ones were the biggest difference. So like, let me go over here to regression weights table. You might take it out into Excel, or you just look at it and eyeball it. You see which ones are totally different. Looks like social desirability is quite different, but we're not worried about that. But you'd look and see with these regression weights which ones are totally different, and then you might try, well, what you might try doing is constraining them to be equal. Here, I'll show you how to do that. in Amos, you'd hit the down arrow. Let's say, for example, we didn't have configural model fit. It was bad, and we looked at the regression weights and we found that playful 4 was totally different between men and women. What we could do is we could double click that one, and in its parameter, call its regression weight something like, it doesn't really matter, I'll call it Bob. So name the regression weight Bob for all groups. And what that's going to do is it's going to constrain this regression weight to be equal across men and women. And so it's not going to let that parameter float freely. And so that one won't affect the chi-square. And the model fit will improve. And the rule of thumb is, if you do that to a not majority of items inside a factor, then you can claim partial configural invariance and still move forward. It's a little looser, but it is a thing. Okay. All right, 30 minutes. We can do this, some of it. We'll hit method bias probably after lunch today. Okay. So we established configural invariance, but to establish metric invariance, which is next, we need to check out the regression weights specifically. And if you weren't sure which to do for which, like scalar, metric, configural, it just says here, metric invariance, we simply perform a chi-square difference test in the two groups, and we look at the structural model of constrained versus unconstrained. So here's how we do it. You click on this multi-group thingy. And then this will pop up and says, we're going to remove any constraints you put on the model. Oh, you know what I should do first? Hit cancel. What you should do first before you do that is remove, reposition constraints on each factor. Notice there's a 1 for each of these factors. Stick that 1 on the factor itself. So the way you do that, double click the arrow that has the 1 on it. Get rid of the 1, and then put the 1 on the latent factor as a variance. So you can see it moves from here all the way to here. And you just want to, I'm just going to put a 1 on each factor real quick in the variance. And then I'm going to delete the ones on their indicators. Why am I doing this? It's because what we're going to do is we're going to constrain the regression weights to be equal across groups. And we can't constrain them to be equal if we're already constraining one of them to be a 1. So we're going to get rid of that 1 constraint. So it should look something like that when you're done. Once you do that, you're ready to click on that multi-group invariance tool. How's the pace? Do I need to? Good. Okay. Almost there. One problem with Amos is it's pixel perfect. If you're having trouble clicking on an arrow, just double click its head, which is bigger, has more pixels to click on. Okay. Once you have that all set, click on the multi-group tool and hit OK when it throws you this little warning. And we're just going to accept the defaults here. Just hit OK. What it's doing is it's going to start constraining paths to be equal across groups, which is what we need. Hit OK. It's going to create multiple models, which we haven't talked about. Look over here on the left. We used to have just the default model. Now we have an unconstrained model, a measurement weights that are constrained, structural covariances that are constrained, and measurement residuals that are constrained. We're really only interested in this measurement weights one. But I'll just show you. Don't do this. I'll just show you. The different models have different parameter specifications. If I were to click on unconstrained here, notice parameter constraints, there are none. We're fully unconstrained, let the models float freely, be estimated freely. If I were to click on the measurement weights, it says all the paths look A 8_1. If I were to click on female, it's 8_2 or 7_2. Oh no! Well, that'll work. Whatever. Okay. It left one constraint on the path. It's actually more proper that way. Okay. But you can see we did constrain across groups for it to be equal. In this measurement weights one, in the covariances, it also adds down here covariances to be equal, etc. So now if we run this, as this is our MGA, let me save. If we run this, after it saves, it's going to take a little bit to run because it's running now not only 2 groups for one model, it's running 2 groups for 4 models because it's running all 4 of these models. So it takes a moment. Remove. Okay.
Doesn't matter if you're in male or female at the top.
Nah, it could be either, as long as you have it correctly identified in the data splitting. Yeah, like you've made sure you allocate the right part of the data to that group. Okay, now we just look at our output, which is hiding over here. There we go. And there will be a new little section here called model comparison. Right here, model comparison. And what we want to do is look at this top row, measurement weights. So assuming the unconstrained model is correct, which is a good assumption, what if we constrain the measurement weights to be equal, all the paths between the latent factors and their indicators? Are they the same or are they different? Well, it turns out those 2 models would be different. Constraining the weights to be equal and letting them be unconstrained, those are 2 different things, 2 different models. So what we infer from that is that men and women are different when it comes to the way we measure these variables and how they're modeled. So that's a problem. We don't pass metric invariance. We need to do something about that. So what we do about it is we go look and see where we're different on structural weights, which would be in estimates, scalars, regression weights. Yeah.
I got very different model comparison p-values than you did.
Oh, you did? Did you run just 3 models? Just the defaults?
Yeah, I mean, I deleted the ones that were the residuals.
Yeah.
Yeah, so if I just look at the weights, one has a p-value that's higher.
Oh, cool. I wonder if it's because I messed this up, this path 1 constraint.
I did not mess that up.
So for yours, for the male or female, they're both labeled as something. Yeah, I wonder if that's my problem there. That could be it. So let's assume you did get a terrible p-value, a really low p-value. Here's what you'd do to fix it. If you didn't, excellent. What you do is you take the regression weights table out of Amos and stick it into Excel. Just paste it in there. So this is just the male group for me. Gotta go down to the bottom here and click female group. Grab that one too. That's a different regression weights. Paste that in there. And then you want to find the difference in estimates between male and female. So some delta here equals this minus this estimate. Oh, did I put them on the wrong line? No, we're good. We're good.
Does it matter if you do the standardized or unstandardized for this comparison?
I prefer the unstandardized because it's it's raw. You see the raw difference. Yeah. So I just subtracted one estimate from the other, and it's a lot of numbers. So let me just use my conditional formatting to highlight top few. Let's see. Top bottom rules. Highlight top 10 items. Yeah. Okay. There we go. So here are the biggest differences right here. Oh, here's the big one right here. Social desirability 9. Do I care about social desirability? I really don't care about social desirability. So for this one test, for a multi-group test, I'm going to delete the social desirability factors. I'll put them back in later. But right now, I'm going to delete them because I don't care about them and they're throwing off my groove. Go here, delete latent factor, delete latent factor, delete all these here.
You're not highlighting.
Why do you delete the whole variable instead of one item?
Because I'm not really concerned about whether social desirability is different between men and women. That's not something I'm going to test theoretically in my causal model. So all of the effect it's having on my chi-square differences is just messing me up, just throwing things off unnecessarily. So that's why I just got rid of them entirely. We'll come back to it. We'll put it back in when we do a method bias test. Okay, so I'm just going to click on multi-group again. It'll reset everything, hit OK. Thinking about it. Just take the defaults. I think. And then we run it. And check that metric invariance again once it's done running. Looking at the output, just like before, there's the model comparisons, just like before, and we still have a problem. Awesome. Okay, so we're still metrically variant, not invariant. We're different metrically. So let's go back and do what we did before, carry out the estimates. You don't have to follow along with this one if you don't want. I'm just gonna do this, copy, paste, paste this in here. Get rid of.
Which estimates are you using the standardized or regression weights?
I'm just using regular regression weights, not standardized. Yeah. And then switch to female. Get this table. Paste it in here. There we go. Biggest differences are now highlighted, and we have biggest one is this one. Information acquisition 4, which is A30_1, and A25_2. Why is it different? That's unfortunate. So the label it gives me, it's just this one, A30_1, A30, and A25_2. These two, when left constrained to be equal, are causing a problem. So what I would do is I go back to here, I go look at the measurement weights model and all these constraints. I'd go find A30 to A25, this one right here. Oop, this one right here is the one that's causing the problem. I would literally just delete that constraint. We're now partial, we're not fully metric invariant. We're entering a partial phase. I hit close, run again, and see if that fixes it. Look at my estimates, model comparison, still no good. So I'd look at the next one, which was, here's the one we did. The next one would be just the one above it, which is A29. This seems like quite a pain, right? Yeah, it is. I'm working on a plugin that does the whole thing for you. Close, run again. And again, why do we need to do this? It's so that we know that the measures that we're using are the same, are measuring the same thing across groups. Because if they're not measuring the same thing, then we can't theorize about them being different, because they're different things.
James, if you had a surplus of items, would you consider just deleting the non-invariant item as opposed to breaking the constraint?
No, I'd still go partial instead of full. I'd keep the items, even if I had a surplus.
Program you may be familiar with that advised the other way. That
just delete it.
Like didn't comprehend this method.
Yeah, you could just delete it.
And just get rid of items that are non-invariant.
You can. Again, you get down to 4 if you want. Yeah. I'm going to try something. I'm going to force these groups to be equal on all the paths, so because it messed up this weird thing. It did this weird thing for me.
Why do you need the male and female to be the same? We are different.
But yeah, so measurement-wise, we want to be the same, but causally, structurally, we want to be different. So we're theorizing. Let me go back to our model. We're theorizing that men and women are different when it comes to the relationships in this model. What we don't want them to be different on is what they consider anxiety to be or playfulness to be. We want them to have considered those measures similarly so that we're comparing apples to apples. When it comes to playfulness, what men think playfulness is and women think playfulness is, again, with computers, we want them to be thinking the same thing, roughly, so that when we say the effect from playfulness to usefulness is different from men to women, we're comparing that the same type of relationship across the spectrum.
So it's the validity of the scale, actually.
Yeah, is this a valid scale for men and for women, and is it measuring the same thing for men and for women?
Thank you.
Okay, I'm going to try something. This got messed up earlier. I wonder if I can just fix it like, go like this. Female, male. I'm going to change mine. If yours didn't get messed up, don't worry about this. I'm going to go fix this real quick. This is a 6 underscore. Nope, this is going to be. No, that shouldn't actually. That shouldn't make a difference. Never mind. Okay, back to this. So we'd go unconstrain the other ones. And anyways, you'd continue to do this by looking at the biggest differences until you reached a point in which you were invariant, metrically invariant, which would mean the p-value here would be greater than 0.05. If you never reached that point, let's say we had to completely unconstrain all of the information acquisition items, all of them, then we wouldn't be invariant. The rule is if you have at least one that's invariant, you're partially invariant, and you keep the whole thing. But if all of them are different between men and women, then that factor cannot be used for a causal multi-group hypothesis. Yeah.
So if you have one item that is non-invariant, would you say you have partial invariance, or?
Yeah, so if you have one indicator regression weight that is invariant, that is the same between men and women, is not different. Invariance is such a terrible thing.
I agree. I'm asking the opposite. If I have just one item that's a problem.
Oh, if there's only one item that's a problem, then you're just partially metric invariant. And you can keep that item. Yeah. Okay. So, but let's say we didn't. Let's say for information acquisition, everything was different for men and for women. I could not then go and test a hypothesis that says the relationship between information acquisition and some other variable is different for men and for women, because the variable is different for men and for women. So I can't test whether the relationship it has with something else is different. So what would I do? I just wouldn't create a hypothesis around that variable, a multi-group hypothesis around that variable. Okay, that clears mud. Invariance is one of the most difficult topics in measurement modeling. Also one of the most difficult tasks, for sure. That's metric. Scalar is one more level. Most papers, most journals are cool with you just doing configural, and that's good enough. Metric is more rigorous. Scalar is the next level, is even more rigorous. I'll show you how to do it. Maybe don't follow along for this one. It's the same approach, but we're going to add one more set of constraints. So what you'd have to do is go to the analysis properties, uncheck modification indices, because we need to estimate means and intercepts, because we have to compare intercepts across groups. And intercepts aren't calculated unless you estimate them. And you can't estimate intercepts unless you aren't estimating modification indices. Don't ask why. It's just the way the algorithm works. So we'd run that through the MGA here, but this time it's going to allow us to create even more groups. It's going to allow us to create, I think it's 5 groups, or 5 models, excuse me. So you just say okay. It runs all 5 models across both groups. Here we go, and run. And notice there are a lot more constraint labels up here now. And we have 5 models now. What we want to look at, just go back to, go back to the output here and model comparisons. And we now want to look at the, where'd you go? Intercepts, right here, the intercepts, and see if they are invariant. And the answer is no, dang. And we have to go through the same process we did with the weights, but this time with the intercepts. I'm not going to show you the whole process. We've just done this with weights, but essentially you go to the estimates, scalars, intercepts, and then you find the differences between the 2 groups. The biggest one, you unconstrain in the model, and then run it again, and run it again, and until you get to a partially scalar invariant model. Okay. Again, the reason to do this is so you know you're comparing apples to apples. If you don't meet the invariance test criteria, you can't create causal hypotheses that split between 2 groups. I couldn't say men and women are different when it comes to this relationship if it includes one of the variables that I couldn't establish invariance on. That's the implication. Now, will a journal call you on this? Probably not. If you never did any of this, they probably wouldn't call you on it. So this is just, if you wanted to go 100% to your rigor, this is how you get 100% of rigor. Will you remember this? No. Only how painful it was. If you do end up needing to do this, now you have a video that goes through it. There are also multiple other videos online on how to do it. But now you have something. All right, there was a question.
Reason why when I'm running it, I'm getting very invariant weights.
So you're getting good p-values?
0.114.
Nice.
Why am I?
So was Rick. I think it's, I messed something up in the labeling up here. So I think that's why it's slightly different or terribly different. Yeah, go with yours. It works. There was a question on the chat. Let's see. In the SEM drive, the slides are there, but not loading yet. Are they still uploading? Oh, slides should definitely be there. They've been there for 7 years. Yes, the videos are posted on YouTube, on my YouTube channel. I can, I'll just paste the playlist in here. Let's see, YouTube. I'll just go to the playlist here. YouTube, SEM Boot Camp 2019. Hey, there it is. Cool. No, that's not. Let's do playlist, comma, playlist. There's 2018. It has not yet indexed my playlist. All right. I'll just go get it from here. Oh, you can't get it from there. I'll get it from playlist, SEM Boot Camp 2019. I want the playlist. They got rid of playlists in the back end. I don't know why. Just go to my channel. Here we go. Playlist and SEM Boot Camp. There we go. I will copy this and paste it in here. There you go. There's a link to all the videos will be posted in that playlist. Okay. Let me go to the slides and make sure I haven't forgotten anything major, and then let's have some lunch because I'm going to pass out. We talked about fit, multi-group invariance. We talked about ad nauseum, invariance guidelines, how to do it, links to videos and the wiki. Method bias is next. So we are not going to hit method bias before lunch. That would be crazy. Method bias is the last thing, I believe, we need to do. Yep. In CFA. So we're way ahead of schedule because we're supposed to finish method bias by 5 o'clock today. So we're doing great. So this afternoon, my plan would be start on causal analysis, everything for tomorrow. Hopefully finish causal analysis so that those who are not interested in Smart PLS don't even have to show up tomorrow. You can do whatever you want, work on your own things if you're from out of town. Go.
Are we gonna be able to do M plus with causal at all? Or?
Oh, would you like to see M plus? We could do that tomorrow. In the morning, possibly. Or I could do both, yeah. We'll see. I'll see how to fit that in. Yeah. Who else is interested in M plus? Okay, you three. All right. Hey, way to go.
It's great fun. You'll enjoy it.
Yeah, right.
I'm not sure what it is, so.
M plus is another stats software that looks like Tad's also interested. Okay. It's a stat software that lets you do more precise modeling in a very much more difficult way, where it's all
much more customizable way.
Yeah, it's all syntax, no user interface. It's just programming your statistics. So it's pretty advanced, but it allows you to do more precise stuff. Yeah.
After lunch, can we just touch on the invariance chi-square difference test?
Yeah. Oh, yeah. We can do that.
Can I ask a question?
Yes.
Maybe it's a stupid one,
Nope.
but I have to ask it because I don't know.
Okay.
So going back to the model that you had.
Yes.
So if I have, let's say I have a scale and it tests intimacy. And it has like 36 items.
Uh-huh.
Do I put all 36 items into this thing?
You include all the items that are relevant to the theory you want to test.
They're all relevant.
And then yes, then you put all the items in. Some people test individual factor CFAs, but that is not a good practice.
So do I use it, if I combine them into 6 subscales? So do I use the 6 subscales as?
They're all part of a higher order factor. That's what you're saying. If they're, yeah, I would test them separately if possible, and then throw in the higher order factor.
I didn't understand.
I would test them all together in the CFA, but at the first order level, the subscale level, and then you can bring them together as a second order factor. You said they are a second order factor?
I have them as items separate, and I have them combined into subscales, and
Yes.
then I have a total mean of the whole thing.
Oh, okay, yes. So you want to test the subscales. Yes, test the subscales. All together.
So if I look at, so if I want to implement that on your model here, so if instead of useful, I put the total, yeah, this one, the total mean of the intimacy, and then in useful 1, useful 2, useful 3, 4, 5, 6, and 7, I will put the 6 subscales of intimacy.
Oh, yeah, you could do it that way, but the latent factor should not have an actual value calculated for it.
Okay. So I will just add the subscales in here in the
boxes. Yeah.
Yes.
Yep.
And then I will do that with every single scale that I have in the study.
Yes. Maybe we should see your model in a little bit. Maybe I can look at it. You can email it to me, and I could answer it more precisely.
I did.
Oh, you did? Okay, good. I'll take a look.
Thank you.
Thanks. I'm gonna cut the recording right now. We'll come back in 2 hours, and we'll pick it up from there. Let's see.